Okay, first you have to select the optic struct as the analysis tool, give OK. So now first it is MHPCLL. So this is the standard code what we are using to solve any problems in the hypermesh. So M H P C L. M means material, H means hyperbeam, P means property collector, C means component collector, L means load collector, again L means load steps. So this is what we are using in the preprocessor. So let us follow one by one. First it is material. You can see here there is a material button is there, click on it, select the material name. So since he has given the steel, you can select the steel, you can assign some color for it. So we are solving with the isotropic properties, and card image you have to select for 1 for static analysis. Just give create or edit. Create or edit, you can select this values here. In question he has given 200 gigapascal. So what we can do is instead of 2.1 you can type it as a 2.0. You can select whichever the properties you want, give return and give create. So now once you click the create, in the materials it will show the steel has been created. So now go to return. So next is the H. So now M is over. Next is the H. So it is hyper beam under 1D. You are having the hyper beam. You click on the hyper beam. So select the standard section, hyper beam. Here you can select the different types are there. For this problem it is a solid rectangle. You have to select the solid rectangle. Go to create. So the new window will come. So where you have to enter the properties. So in question he has given like 60 by 90. So usually 60 by 90 means breadth into height. So what we can do here is this 60 is the breadth. Instead of height we can take it as a as per this window. We can see here he is showing this A in the y direction. So therefore we can type it as a 90, and for the other one you can type it as a 60. Enter. So give F, you can see here. So A is 90, B is 60. So here go to model view. So now H is over. So after H is over, what is the next? It is P, which is a property collector. Where it is? So you can see here properties. You click on the properties. So property name it is asking. So we'll give it as a beam properties. Color it is asking. You can select any color, and ID it is 1D problem. Card image it is with the property of the beam. Material you have to select what material you created previously. Beam section that you have created previously, rectangular section 1. Give create or edit. So here I have to go with the continuation line 2. What is continuation line 2? There are some coordinates values it is asking, that you have to type here. See, before typing those values, let us know what are exactly the coordinate values. So usually we are having the XY axis like this. So in case of the beam will represent like this. This is the X and this is the Y, and here will show like this is the Y and this is the Z, which means this cross section which we select means this is the Y and this is the Z, and this is minus Z, this is minus Y, and this one it is 0, 0. So now if we place this rectangular cross section exactly like this, so usually he has given this as a breadth 60 and this height he has given 90. So now if the center one is 0 comma 0 means, then what is this value? So along y axis 90 divided by 2 means it is 45, it is positive 45, whereas the bottom one it is minus 45. Whereas in the horizontal way it is 0, sorry, not 0, so 0. In this case also it is 0, which means I am just writing the y comma z values, that's it, at different points. So 45 0 minus 45 0. In the same way z values we have to write. So start from here. So exactly at this point it is there, it is 0. So next, so this is positive, therefore it is 30, and again this is again 0, this is minus 30. So this point we are calling it as like, we are calling these points like, this is the point C, D, E and F. So now the C value is 45 comma 0, D value is 0 comma 30, minus 45 comma 0, and finally F is 0 comma minus 30. The same values you have to type here. In the C column, first one it is 45, again 0, in D column 0, again it is 30. In the same way, E value minus 45, 0, 0, minus 30. So likewise you have to type. So now go to return. Now give create. So we can check here this properties. It has created the beam properties. Go to return. So now C is over. Next is the component. So where it is, here you can see the component collector is there, click on it. So component name you can type, I will type it as a beam 1 2 3, you can type anything just for reference. You can select some color. Property, you have to click on the property, you have to select the previously created one. So now just give create, go to return. So now component is created now. So next is the load collectors. So before creating the load collectors, what we need is a model. How to create the model? So now that is geometry. Go to geometry. First create the nodes. So XYZ coordinate 0 by default is the first one. Create. For second one, the total length is given 2000 mm. 2000 mm. You type the X value as 2000. Give create. You can't able to see the nodes in the screen. What you have to do? Type F. Now you can see that 2 nodes is coming. So next what we can do is, if you want you can create the intermediate nodes between these 2 points. How to create it? So here you can see the fifth option, interpolate nodes. You click on interpolate nodes. It is asking the first and last node. Select the nodes. In between, how many number of nodes you want, you can type there. For timing I will create 4. I will give create. Now you can see. Just go to return. You have created only the nodes. Now you have to create the geometry. What you have to do? Usually beam is a 1D element. Go to 1D. Under 1D, you have to select the bars. So even though it is a beam, you have to go with the bars only. The reason is, here there is no beam element option. We have to select the bars. Bar is just a line. So later we have to apply the properties, that is the beam properties. How we can apply? Just click on the bars. So now you can see here it is the property it is asking, the beam property as an element type it is asking. So this element type you convert it to beam, that's it. So orientation you have to select it as a y axis only. So now create the node AB it is asking. Click for the first, second. In the same way first, second. Select the pair of nodes, that's it. So now you just give ISO view. Now you can see it is showing something like C beam, which means it has created the beam element. So go to return. So I'll go with the XY axis. So now have model created the model. So next is the L, that is the load collectors. So I have to create the load collectors. For this, what I have to do, here you can see there is a load collector is there. Click on it. First load collector name I will give it as a SPC. The meaning of SPC is single point collector. I will assign some color to it. I will just give create. Now you can see in the load collectors SPC has been created. In the same way, second one you create it as a by typing force. Give create. Now you can see two have been created. Go to return. So after this we have to apply the load. How to apply the load? Go to the analysis. Here before selecting the constraints or the force, here first one make SPC as the current. Right click, make current. Now you select the constraints. Select the first one. Make sure that here all DYF should be selected. Now you just give create. Now you can see it is showing the arrow mark with 1, 2, 3, 4, 5, 6, which means all degrees of freedom is fixed. So go to return. Next is you have to apply the force. Before applying the force, under load collectors, you make the force as current now. Make current. So now click on the forces. Select the last node. Type the value it as minus 4000. Yes, given in question 4 kilonewton. So therefore minus 4000. Y-axis. Create. Now you can see it is showing the arrow mark, which means the force is acting downwards. Go to return. So now load is over. The last step it is load steps. So load steps. So where it is analysis, load steps. So now we are solving it for the bending of a beam. I'll give like a bending. So what type of analysis is this one? It is linear static. So now you have to select the SPC and load. So now select the SPC with SPC, load with force. Give create, return. So up to now it is a preprocessor. So now let us check whether what the data we have created is correct or wrong. So go to the analysis, OptiStruct. So here export option you can select all. Run option you can select it as analysis. So now you have to save the model. Go to return, file, save as. You can create some folder. Under folder you can type the name for this. I'll select it as a beam. Save. So now go to analysis, give OptiStruct, again OptiStruct. You just wait for it. The another window will come. It will show for any error. So now you can see analysis complete it is showing, and you can see there is no error it is showing. So now click on the results section here. Results. Just wait for it. Another window will come. So now I'll select the XY view. So here go to contour plot, similar to the ANSYS contour. Displacement, you have to select the displacement, and you can select the Y component displacement. Apply. So you can see it is showing the values 1.46, or else you can directly select the magnitude, give apply. Now you can see 1.46 10 power 11, 1 it is showing, which means 14.65. Is it correct? Let us see with the theoretical value. It is 14.6 mm. Here also it is showing 14.65. So it means results is correct. If you want to see the animation, what you can do? You can click here. You can select the speed. Now you can see how it is displacing. So in the same way, select the stress. So here we have to select SAC. The reason is see, this is the point. These 2 points you are having. You know about the hacking and sagging. Usually the beam, it will undergo bending like this. So which means this top will be under tension. This top will be under tension and bottom will be under compression. So therefore this point, it is corresponding to the C point. So therefore we have to select here along SEAC, give apply. Now you can see the value it is showing 98.77. Is it correct? We can check with the theoretical value 98.765. So which means the answer what you obtained, it is correct.